We will learn one of the most important recursive function, Ackerman function. So what is Ackerman function? Ackerman function is a well-known recursive function defined for m greater than equals to 0 and n greater than equals to 0 as follows. When m equals to 0, amn equals to n plus 1. If m equals to m greater than 0 and n equals to 0, then amn equals to am minus 1, 1. And if m greater than 0 and n greater than 0, then amn equals to am minus 1 and amn minus 1. See one example how it works. First, amn, where m equals to 1 and n equals to 2. You have to calculate what is the value for a12. Now see, a12 means m greater than 0 and n greater than 0. So we can apply rule 3. So applying rule 3, we get m minus 1. M minus 1 means what? M is 1. So m minus 1 means 0. And m n minus 1. M is 1 and n minus 1 means 2 minus 1. So it is 1. Now you have to calculate what is a11. A11 means which rule we can apply? We can apply rule 3 because here am greater than 0 and n greater than 0. So again we apply rule 3. Applying rule 3, it is am minus 1 and am n minus 1. So it is m minus 1. M minus 1 means 1 minus 1 0. M n minus 1. M is 1 and n minus 1 means 1 minus 1 0. Now a10. What is a10? M is greater than 0 and n is 0. So we have to apply rule 3 here. Rule 2 here. So when we apply rule 2, it becomes m minus 1, 1. So it is m minus 1, 1 minus 1, 0 and 1. Now it becomes a01. When it is a01, what is a01? A01 means here m equals to what? 0. So you can apply rule 1. So a01, m equals to 0. So we can apply rule 1 and we get the result n plus 1. So it is 1 plus 1, 2 by applying rule 1. Now when a01 equals to 2, then we can say 10 equals to 2. So when a10 equals to 2 and when a10 equals to 2, we can write a11 equals to a02. A11 equals to a02. Now when a02, what is the value of a02? Which rule we can apply? It is m equals to 0. So you can apply which rule? The first one. By applying rule 1, we get a11 equals to what? A02 equals to 3 because by applying rule 1, m equals to 0. So a02 equals to what? N plus 1, that is 2 plus 1, 3. So a11 equals to 3. So a11 equals to 3. So when a11 equals to 3, so what is the value of a12? A12 equals to a03. And here a03 means here what is the value of m? M is 0. So again we can apply rule 1. By applying rule 1, we get a12 equals to 4. So this is Ackerman function. Now the programming for Ackerman function. So this is the code for Ackerman function. So these are the rule. Now see, this is our recursion function. You have to pass the value of m and n. So if the value of n equals to 0, then you have to return what? N plus 1. Else, if the value of n equals to 0, means if this case false, so m is greater than 0, then you have to come to else if part, and now n equals to 0. So you have to return m minus 1, 1. And if this case also false, both m greater than 0 and n greater than 0, then comes to else part and return m minus 1, comma am, comma n minus 1. So these are the three rules. First is m equals to 0. Now if m not equals to 0, then it is greater than 0. If it is greater than 0, then check whether n equals to 0 or not. If n equals to 0, you have to apply this one, rule 2. And if n also not equals to 0, then both are greater than 0, then come to else part and return the last line. Now you have to call this function from main. So give the value m and n to the user. Here it is 1 and 2 in your case, 1 and 2, and call the function. See, I am calling the function from here and get the result. So this is the code for Ackerman. Wait for a second. So this is the code for Ackerman function. See here, this is the main part. I am giving m and n and value, and these are the code for Ackerman. And when I run the program, supply the value of m and n. I am giving 1 and 2 here, and the result is 4 here. So pause your video, go through the program, try to run this program in your home and practice this program. Now your task is to solve what is the value of Ackerman 2.1 and Ackerman 2.2. First solve it manually and then run it by giving this input and cross check and verify whether your answer is true, wrong or right. Now answer me in the comment section what is the solution of these two problems. What is the result of these two problems? That's all for today. Thank you.